My class usually don't ask you to explain the device physics, right? But I would like you to, really like you to understand it's for yourself. In the future, you want to be a great circuit designer or do great in the interview. You do need to understand this, right? You cannot just say, let me wiki, let me Google. And no one is going to hire you. But if you understand the basic, that is great, right? But for the exam, and as a circuit designer to yourself, we really don't need to memorize what I just said, right? Now, you can make use as like a machine, just do the programming. So now it comes with a unified model. Then we have free mode. ID equal to 0. If VGT less than 0. Here VGT means VGS minus VT. You know that already because it's threshold voltage, right? Less than threshold voltage. That is fine. So this is off state. We learned this in undergraduate. But now we modify the on-state equation into only one equation. No longer two equations, okay? But it takes care of three things: linear, velocity saturation, and pinch-off saturation. So let's look at the equation. It's very similar to what we learned before. First, K dash is not mentioned here. KT over Q times mu ox, right? That is okay, right? We usually just call it K dash. W on L, no problem. Here is VGT, which is VGS minus VT times V mean. Minus V mean squared divided by 2 times 1 plus lambda VDS. This is lambda, 1 plus lambda VDS is just channel length modulation. This looks like very much the linear mode equation, okay? But what is V mean, okay? The summary is so simple. V mean is the minimum of VGT, VGS minus VT, or VDS, or VD set. If you cannot see it now, let's do it one by one. What if VDS is the smallest? Then this equation become ID equal to K dash W on L VG. I want to spell it out so you can appreciate VGS minus VT, which is VGT, times what? When VDS is smallest, I put V mean as VDS, correct? This becomes VDS squared divided by 2, right? This is just the linear equation we learned earlier, right? So this one reduced to that equation if it happened that this is the smallest. Okay, what if VGT is the smallest? VGT is the smallest. Okay, let me just plug in K divided by L, VGS minus VT. VGT is smallest, that means V mean. Here is V mean. I'm going to plug in V mean as VGT, which is VGS minus VT, minus VGS minus VT again, but square divided by 2. But obviously, this is square minus half, right? So what is this equation? VGS minus VT squared divided by 2. Hey, this is the same as our pinch-off saturation equation we learned in undergraduate class. Is this okay?
I have a question regarding the Vmin.
Mm-hmm.
So in order to determine like whether it's VGT or VDS or VDSat, do we just have to like do trial by error and just test each one, or is there one that's like typically going to be Vmin most of the time?
You need to do trial and error, but based on the equation, for example, you see the voltage is small or the gate length is short, then maybe you will start with VD set because you assume it's in velocity saturation. Yeah, but you need to do it by trial and error. You cannot see it in a circuit. Yeah, so you will see that in the assignment also. Okay.
Yeah, the VD set is typically like 200 millivolt, right, Professor?
Yeah, depends on technology. So it will be given to you.
Got it.
Yeah. So how about if VD set is the smallest? Well, this is not that difficult. VGS minus VT, then you just put in VD set minus VD set square divided by 2, right? We don't know this equation before, but now we will use it. And this is due to, this is again is saturation due to velocity saturation, okay? Current saturation due to velocity saturation. And that's it. That's the model that we have. Any questions? Right, so it's not too difficult, right? Only one equation. Take the minimum one. And then the threshold voltage, again, take the body effect into account. Right, so how good is this equation? Again, this is just a model, right? So we try to compare to SPICE. You see that it fits pretty well, except in a certain corner region, right? But now we can try to appreciate this graph now. You see that on the left, this is linear region. Linear region is talking about what? VDS is the smallest. VDS is smallest, which makes sense, right? Isn't that we have the very low VDS? Linear region cannot be here, right? Here, velocity saturation means VD set is smallest in this region. Does it make sense? It does, right? Because when this curve are talking about high VG, so high VG minus VT are large. This part, VG minus VT is smallest. Makes sense because this is low VG. Of course, VG minus VT is smallest. When this is low enough, it's smaller than the VDS. So then you have free region, right? In the past, we only care about so-called linear region and then saturation rate. But now you see that we have linear saturation due to velocity saturation on the top and then the pinch off at the bottom. Is that okay? Okay. So how about PMOS? PMOS is exactly the same. The only thing I want to tell you here is that it's about my trick, right? How do I memorize the PMOS equation, right? This is my way. You have your way. Right? You have your way. Feel free to do your way. But I always just do what? I just make ID to be absolute ID. Okay? VDS, I use absolute VDS. Okay? Because in a PMOS, it will be something like this. I told you this is S, right? This is what? This is drain, right? This is gate. In a real PMOS equation, IDS is negative, right? Because this VDD, the current is flowing from top to bottom. So how do I memorize all these things? I don't want to. So I just use MOS equation. But I try to use the physics to guide me. I know that if the absolute value, right, of the VGS is large, it means VS is much larger than VG. Then I have larger current. Right? So I will going to do this. I just tell myself IDS absolute value, right, is proportional to VGS. Again, absolute value, VTP, absolute value, square, for example. Then I won't make any mistake, right? You have your own way, doesn't matter, but just be careful about the sign. Is this okay? So I think maybe